What's up Flutter aliens, welcome back to another video of Flutter and Firebase Developer Bootcamp's week 5. In this last video of week 5, we are going to finally go ahead and bind all the logic back to the UI, and we will also be dealing with Agora for calling. So let's get to it. First thing first that I want you to know is that there are some permission requires that I need to add in the Android manifest.xml file. So inside the Android app, inside the source man, inside the Android manifest file, these permissions need to be added for having a call in your Android emulator, its real device, or also the iOS simulator. So these are the permissions that are within the documentation of the Agora UI kit in the pubdev. So these need to be added inside your Android manifest file, and also for iOS, the only permissions required are the camera and the microphone, and that's it. And we already added them in the previous video, so we don't need to go again to the iOS by opening it in the Xcode. And also one more thing here I want you to show is that there were one more feature that needs to be added, and I just directly added, and I'm just gonna go and show you how this is working. So the feature is update call history status. So what this feature is going to do is when someone decline the call, so the call status will be updated for both of the users that were connected in the channel, and the is missed field will be updated to true, so that in the call history page we will consider that call has been missed. So this is what this feature will be doing, and here it has a use case for that, and we have the implementation of the repository, the same here, and the actual implementation is here. We are accessing to the users. Inside the users on the caller and the receiver ID, the two users that will be connected in the channel when a call is made, and their call history of both of the users. We are creating empty maps for both, and we are checking conditions on the same fields is called dial and is missed, and passing the data to the similar keys in here and storing them in my history info and other history info, and then simply on call ID we are updating the my history and other history info, and that's it. So whenever a call is missed, so this method will be called along and will update the is missed, or if you want this to be updated, so we can also do that. So this is a simple feature, update call history status, that I added in order to save our time and not go back in the video by following the same way and adding this feature again. So there is a lot to do in this video, so I just didn't want to waste more time on this adding single feature, so I just added, and this is how it's look like. Anyways, let's go forward, and we added the permissions, we added the single feature, and now next thing you have to do is to create an app inside the Agora. To do that, you have to move to your browser, and in the URL you have to type Agora in here and then move to this first tab. So once you get here, you have to log in. So once you're logged in with your account, you have to create a project by clicking this create project, and your project will be created like this. Now you can go ahead and edit that project from here, configure. You can change its name and select the use case in here, for example social and the chat room, and that's it. That's all you have to do. We only need the app ID and the app certificate from this, so that we can generate a token and use it in the Agora UI kit where it's required, and I will explain the scenario of the token URL when you go forward, when we were building the node server which will generate a token for us, and then we will pass that token URL to the Agora server. So everything will become clear to you when you go forward for that step. So all you have to do is to create the project like that, and I already have one which I am using. Here it's WhatsApp, so I will go to the configure, it's test project, so I won't hide the IDs in here. So this is the project I created. Once you have this, we have to go to the Android Studio, and inside the app feature, inside the const, you need to add Agora config const.dart, and inside that will be a class of Agora config where the Agora app ID and app certificate will be added, and these are the certificates of the project that I have in here, this app ID and this primary certificate. So I just passed them in here so that I'll be using it in my project. And if you're building a production application, so these are the secrets, you have to keep them hide. You can create a git ignore in here. We already have one, so you simply can ignore the files as it happens in here by doing dot and the file name. So you can have an .env package in your project by simply adding them in the pubspec.yaml file, and then in the .env environment variables you can add these configs and simply ignore that env to uploading it in the GitHub. So only in case if you are working in production applications and you have the secrets like that. So once you have this Agora config, the next step we have to do is to create the Cubits and then inject all the classes of the call feature in dependency injection. So inside the presentation layer, we have to create the directory of Cubits. Inside the Cubits, we are going to have 3 Cubits. That would be these 3 Cubits of Agora, Call, and my call history. The Agora Qubit is going to be for taking the instance of the Agora client provided by the Agora UI kit, and then some initialization and the cleaving channel methods. And the call will be for simply retrieving if the user is calling that method and the other invocations of the use cases. So this is a primary qubit of the call, which will be invoking all the methods like making call, int call, and save history, all of that stuff. And the my call history is going to be just to get the my call history from the method that we have added in the previous video in the repository. So let's go to the Agora Qubit. Here we have created the instance of the Agora Qubit. In here we are accessing the internal, which is the private constructor of the Agora Qubit, and then from the factory we are returning that instance, which means that every time when we take the instance of the Agora Qubit, it won't give us the new instance every time where the client won't be initialized, but it will give us the already existing instance of the Agora Qubit. And yes, we are also going to initialize it as lazy singleton in the injection container. So that's what here is happening. We have taken the instance of the Agora client, which will be null until the initialize method is called, and when the initialize method is called and the client was equal to null, then we will initialize the client with the Agora client. It requires the Agora connected data, and this is the instance provided by the Agora UI kit. From the Agora UI kit models the connection, and the app ID is required, which we take from the Agora config that we just created in here, and then the channel name will be the channel name that we will be passing, and the token URL will be that token URL that I just talked about previously sometime before. So I'm going to explain the scenario of the token URL once we get to that part. So that's it. We will initialize the client after this step has been done, and then we will, if required, we will leave the channel. When the client was not equal to null, we will leave the channel and will release, which is going to release the RTC engine instance to avoid the unexpected exceptions from the Agora RTC engine. So this release is because I was facing the same issue which is created in the Agora IO extension, Agora Flutter SDK. So I was facing the same issue, and here I found a solution. After I called the engine.release, it seems to have disappeared. So there were a lot of logs when I was testing in here. When I leave the channel, call leave channel, then this log appear, the strategy chain not found timer type. So once I do release, then it disappears, same as this guy said here. So you have to call this to release the Agora RTC engine to avoid unexpected exceptions in here. So that release is necessary for that. And here we have a simple get method, which is getting to the client that we have created in here. So that is a simple Agora qubit in here. And then we have the call primary qubit of the call feature, which is holding about 5 use cases as dependencies, and then user calling the main method it's having, and here it has the stat of is calling. I have created the stats of is calling and call dialed, call failed. So I have the stats. So whenever is called, is calling will be called, and it will send the request to the get user calling, passing the UID of the user, and then it will listen to the stream. It was empty, then we will return the call entity. Since we're not passing anything, will be constant, otherwise it will return its first item, that will be that user who is receiving the call. So that's it. If the socket exception occurs, we will emit the call failed, and otherwise we will still emit the call failed. And when we are making a call, we will first emit is calling and then make call use case call and then call. The same for int call, and then save calling history, and then update call history status use case, and that's all. So this is the qubit, the primary qubit of the call feature. Then we have the my call history qubit, which holds only one instance of the get my call history use case, and then the same method of the get user calling, simply sending the request on the use case by doing .call, passing the UID, listening to the stream. Once we got the data, passing to the loader state, and then simply we will load it in the UI where it's required, and this would be required in the call history page. So that's it for these qubits. Now we have to create one file inside the call feature, that would be the call injection container. And once we have this call injection container, we have to inject all the classes of the call features in here. So here will go all the injections of the classes: call injection container method, injecting the qubits. These two will register as factory, and this will be registered as lazy singleton, because we want the same instance for the life cycle of the app of this Agora qubit, and then same lazy singletons for the use cases, and then the repository and the remote data source and the file store is already registered in the main injection container. What we have to do in here, simply to await the call injection container, and that's it. And lastly, inside the main, we have to provide these. So we will copy this, paste it in here 3 times. Since we have 3 qubits, that would be the call qubit, and then the my call history qubit, and lastly the Agora qubit. So our main task has been done. Now it's time to go for pages, creating 2 pages. That would be really simple, and then simply creating the make call methods, and simply exploring the server and taking the token URL from here, and then we are good to go for testing. So now let's go and create the pages. Here inside that, we will create one page of call page, and then one more page will be required. That would be the pick up call page. So once we have these 2 pages, first we are going to go ahead and implement this call page. The call page is going to be very simple stateful widget. Here in the init stat, we are calling the initialize method, and the call channel name will be the call ID. As I said in the previous video, we have the unique identifier, and that would be the channel name. So while initializing the Agora, we are passing the channel name as the call ID, and we are going to have this call ID because this call page will be called after when we call the make call method from the primary qubit of the call feature, this make call. When we call this make call method and passing the arguments, and 2 instances are created in the call collection, so we are going to have the call ID, and after that we will navigate to this call page, and we are going to have this call ID in here. So that's how the ID will come to this call page when we make a call. And this token URL will be for now empty, and we will come back to this step after a while. In the build method, we are accessing to the Agora qubit from the context, since we have provided, so it's accessible. And then we are checking if the get Agora client was null. Then we have to return the center circular progress indicator with a tab color, otherwise the safe area of the stack, and the Agora video viewer, so it's creating the UI for us in the stack. These widgets are provided by the Agora UI kit. Here from the UI kit, it's from the layout, and in the client we are passing the client, and in the Agora video buttons we are again passing the client, And the disconnect button child, we are creating the icon button of red color, and it's of the call int. When is call, we will from the Agora provider, we will leave the channel, and then we will call the int call method, so that 2 instances created will be deleted from the CloudFire store database. Once it's done practically, I will show you how this is going to look like and how this is going to work. So this all will be happening in the call page. So once we have this call page, so we will be navigating here, so we need a route for that. So now we have to modify the on generate routes, and we have to copy this one and paste it down here and simply do call page. We already have the constants. We will do here the call entity, and here we will return the call page, and will be the call entity passing the arguments, and that's it. So once we have this call page, now we have to create the pickup call page, and then for navigating to the call page, we will later write the make call method. It requires some more work, so other methods will be calling along with that make call method. So first we're going to complete the UI, and then we will go towards this. So let's go for pickup call page, and here this page is also going to be simple. There won't be any complexities. So this is going to be our pickup call page, and it accepts 2 parameters and is UID and a child. The child is because this is going to wrap the single chat page, and here we will display the pickup call page UI. And this page will only become into shape, for example, will become visible whenever the make call method is called, because here we are calling the get user calling, which is getting the users in the calls collection if their instance exists. So this instance only come into place when we call the make call method. So this page will also show up whenever there is instance. So we will here build the qubit. So here we will do block builder, and then when is call dialed, this stat is emitted. Then we are taking that call, and we are checking if is call dialed was false. So for both of the user on their ID, the get user calling method will be called on their single chat page, and for the current user who called the other user, in that case the is call dial will be true, so he won't see this incoming call page. But the other user, let me show you in the remote source implementation, the other user who is receiving the call is going to have the is call false, so he will see this pickup call page where we are returning the simple scaffold column. In the center we have the text of incoming call, some size box, and then the image URL of the receiver and his name, and then we have the row in here. In the row we have the icon button, so whenever this is clicked, the red call, which means that call in, so we will leave the channel and will update the call history status where is missed will be true. So there will be the call history created after the make call. I will show you when we create this make call method, so that's why here we are calling the update method. So for both of the users, when their call history was created, so in there on the call ID, the is missed will become true, which means that we can show different UI, which means the red arrow icon, which means the call has been missed, and you will see this when you go forward for the call history page. And then once the history is saved, we will end the call. Then if in here, if we click this green call icon button, so what it's going to do is to get the channel ID, call channel ID on the receiver ID. So there will be the instance of the call since these are connected, and that's why he's seeing the pickup call page. So there will be the receiver ID, and then we are sending the request on this get call channel ID use case. We got the call channel ID. We are calling the navigator push name to the call page, so this receiver user will also be navigated to the call page, and then user who is calling to this user will already be in the call page because the make call will directly move him in here. So when he click, that receiver user click the this green call icon button, so he will also be navigated to that same call with that channel ID. So both will be connected in the same channel since they are going to have the call channel ID the same. So this was a simple CallPage, and otherwise, I forgot that, if the isCall was true instead of false, or if the callDial method was not emitted. So we will in both cases return the child, which will be the child of the single chat page. So once we have these two pages, very simple pages, I explained them bit by bit that what's going to happen in each step. Now we have to go to the chat feature inside the presentation layer pages. In the pages here, in the single chat page down here, we have to wrap the main scaffold, where it is here, with a widget, and that will be PickUpCallPage, and as UID we will pass the widget.message.sender UID. So for both of the users, they will be their senders. So for both of the users, the call page is going to work the way as I explained. If none of the state was emitted, we will still show the single chat page. Otherwise, if some call occurs and there is got the instance in the call collection, then it will, for one user, we will navigate him to the call page, and when he also collect the receive call, so he will also be navigate to the same call by doing the call channel. Since in the call, what we are doing, we are initializing Agora again in the call page, not the chat, with the channel upcoming here. So that's how they will be connected in one call in the call page. So once we have this, now inside the chat utils, we have to write here a method of make call. So now everything, your confusions will become clear to you, that what was that call method and how this is going to work. So down here, we are going to do create a static method of future void and pass the context inside, since we will be calling the block provider method, so it requires the context and the call entity, so that we can access the data of the sender and the recipient user from the single chat page, and we'll pass them in here. So when we make a call, we will pass the caller ID, the caller, and the caller name for the caller profile and the receiver and all of that. And once the make call create the instances, then we will go ahead and get the call channel ID on the caller ID. And once we have the call channel ID, we will navigate this user to the call page by passing the call channel ID in here and the caller and the receiver ID. And when this has been done, we will call from the call qubit, save the call history, the call ID will be the call channel ID, and then the same for caller ID, caller name, and then all of that stuff will be same. And the isCallDial and isMissed will be false in that case, and this isMissed will be updated as you have seen in the PickUpCallPage when the user decline the call. So this isMissed will be called, and this will be updated to true for both of the users, so that we know we have to show the different UI. So this is a simple method doing different tasks. First creating the instances, then getting the channel ID, then navigating the current user to the call page, then saving the history. And then if other user got the pickup call page and he has to either receive or decline the call, and the history will be created like that. Now one last thing here in the single chat page that we have to do is to call the make call method, and that will be called in here. So we have to remove the const from here, and we'll wrap this with a widget JSON detector. And when it's tapped, what we are going to do in here, we will from the chat utils call the make call method, passing the context of the single chat page build method, and the call entity will be the call entity, and passing the caller ID will be the sender UID, and the caller name will be the sender name, and the recipient caller profile URL will be the sender profile, and the same for them. And for the others, we will add the constant like this, and this will do all of the things for us. And now when we make a call and we navigate to the call page, so we will get the error that I show you, this strategy chain not found, because the Agora use token based authentication to validate the identity of each user before they can join a video call. This kind of authentication is typically done on separate server to decouple it from the client side app. So as I said, we're going to have a server. So you can either download this Agora token server from my GitHub repository, which can create a server for you. And you also need to deploy this code such as on Heroku and to more service providers like Render and Railway. And yes, this time they also required billing. So when I was creating the WhatsApp clone initially, and I created that Agora Token server and deployed it on the Heroku. So just for testing, I deployed it in here and my calls are working. It gave me the token URL and I was using that, and the server was generating the token for my users to connect in a call, so that everything was going fine. And I created that WhatsApp clone before I was creating that bootcamp. So in there I just connected about few users and about few times to connect them in the call, and then I left that code and I start working on other things. But still, the Heroku service providers make the $17 bill for me that you have used our service. So I don't know what was happening in there, what was the situation, how they were making the billing for it. Even I was not using it. I just left that, but the service was connected with my Flutter application. So I don't know what happens, but still it makes $17. So I had to delete the account from here after paying them the $17. So initially, before it was not required with the payment, but now it requires your credit card, so that you have to put the details and then you will be allowed to create the app in here, and then they will give you the token URL, and then you have to deploy your server in here in the GitHub, and then everything will be done set up like that. But here now in our case, we will be using the local node server for generating the tokens. And yes, for production you can consider some other services like, as I said, Heroku. So if you are production, so you might have that much amount to purchase the services for calling, or you can also consider some other services. There are a lot of, and for this case, for this application, we'll be using the local node server to generate the tokens. So here in the call page, we left this empty. So what you have to do, you have to set up the node server. This is basically my gist in the GitHub. I just wrote the readme for that to show you how you can create your node server in here. So to set up the node server, you have to first create an empty directory, open it in VS Code or any editor that you have, and then run the npm init. And you also must have the npm installed, node package manager, and then you have to install the dependencies and install the express, because we'll be creating an endpoint, then we'll be calling it in our Flutter application. So you have to install the express, then you have to install the Agora access token, and once you have this file in the node.js, in the package.js, sorry, and then you have to create the file inside the project server.js. Then you have to run it by doing the node server.js, and once you get the log in your terminal that Agora server is running, then you are good to go. And I also show how you will configure your URL in your Flutter application, and this will be the way. So this is the code you will be pasting in the server.js when you create one, and here goes your app ID that you have here in your project, and that app certificate will be that certificate. And then what it is doing, simply taking the channel name, and then if the channel name was empty, then it will throw this status of 400, and in the error we will say channel is required. And then here what we are doing, taking the expiration time in the second from the current time, we are adding the expiration time with the current timestamp, storing it in the privilege expired timestamp, and the role will be the publisher, and RTC token builder build token with UID and the app ID, app certificate, channel name, and passing that parameters in here. And then in the response we are sending the token, and then we are listening to the port, and we are seeing Agora token server running on the HTTP localhost port. So the localhost will be not in the case. In our case, we will be using our IP address in here and then the port to make the get token locally work with the node server. So I already have created this. You can see in your node project, you're gonna have the files like that. So I have the server, the same code in here, and then when I do node server.js, then it's running like this. Then to get the IP address of your network that you are currently connected with, you have to go to the settings, and then inside the network you have to go to the details to the internet that you are connected with, and then inside the TCP IP you have to copy the IP address, and that will be different every time. So you have to copy this to configure your token URL, and then here in the token URL you have to do to configure your token URL just like that, doing HTTP and the IP of your internet, passing the 300 port name and the get token endpoint and the question mark, which means that we are passing the parameter in here which will be equal to the widget.call entity.call ID, the channel name. So once we have this URL, then our calling will be working. And since the server is already running, so this is going to work. So once we have everything set up, now we have to run our application on the emulator and also on the real device to test it out if the calling is working or not. So now we have our emulator and a real device running. So now it's time to go for testing. So in here we will go to the John conversation and here like that, and for him we will also open that, and it's saying WhatsApp clone app allow. Okay, we will allow this, it's required for permission, and then you can see both are online, and that's it. Now let's make a call to the John. So when I do so, you can see here I got the incoming call, and here I am navigating to the call page and it's connecting. Okay, I will allow the app to access the camera. It's connecting, it's connected now. You can see I got it here. So this is the default camera of the emulator here when I receive the call. So I also be navigate to the call page to the same channel, and for some reason the Dart compiler closed unexpectedly with the real device here, that in Phoenix. So I will simply, for now, let's close this. Okay, now let's test it again. Let's come to this conversation, and here let's say now he called again to the John. When he do so, he will be navigated to the call page and he's receiving the call. And once he receives the call, he will also be navigated to the call page, and this time again while using this app, the camera must be connected, and yes, it does. And you can see everything is connected up. So that's how the call is connected, and we are doing the call. You can see this is a real device. I can move the camera, and let's say then now close the call. The other user is left and the other is still in the call, and when I close for him also, so he will back navigate to the single chat page, and that's how the call is working. Now for him, when you go back and go to the calls, there is a dummy history in here. So now this is the time to populate the call history. But also one more thing that I want to show you is that when I go to this profile again, and let's say I want to make one more call in here, I navigate to the call page and it will connect it up like that. It's connected now. The other user will have receiving the call. When he go to this page, he received that call. Now both are connected. I'm just silencing my MacBook to stop him from making noise. And now when we go to the cloud file store and restart this, and you will see the call collection. Here we got it. We have two instances of the two users, and you can see there is data. But when the call is ended like that, this user left and this one also. And now when we go back and restart, you can see there is no instances in here. There is no need to restart, so the call is deleted from here. So that's what I want to show you. And for the history users, let's say in the call history we got the history 3 times, the one that was unexpectedly closed, the other application, and these two fields are false, which means he received the call. Here is still false, and this is also false. And then for this user, this will be the case, also here false. So now it's time to go ahead and let's load the call history in the call history page. So this is also going to be very simple. In the call history page, what we have to do, so I modified the call history page. This time it's accepting the current user. We are wrapping the single child scroll view with the my call history qubit, and when it's loaded, we will extract the my call history, and then here if the call history was not empty, we will show the text of recent, like in here. Let's go back. In the call history, we have this recent. So when the call history is not empty, we will show the recent, otherwise we will show no recent history. And the list view builder, we got the length of the call history, we extract the single history item, we pass. Here we are simply checking the conditions. The profile, we are checking if the caller ID was the current user, then we don't have to show, then we have to show the single call history dot receiver profile URL, otherwise the caller profile URL. So simply we're saying if we are the callers, the current user, then we will see the other user data from the call history data, otherwise the caller data. And then if the same condition is here, if we are the caller, then we will show the receiver name, otherwise the caller name. And the same, the caller ID was the current user ID, we will show the call has been made, otherwise the call received. And if is was true, we will show the red, otherwise the green. And the created at time is for single call history and to date, and the format date time is to tag we created in the first video, and now is last video, just to tag the today, tomorrow and yesterday time from the timestamp that we are passing. So that is it, what is happening in here. Now once we have this setup, we can go ahead to the home page, and here now this is the final step. We have to remove the constant and we have to pass it, and then this will be the call and will require the current user. We already have the current user in here, so we'll pass it like that. And you may have seen we have not called the get my history in the my history page here. We still have the stat list widget in here, and we are going to call the method in the home page, and we are simply sending the data in here. Since it's directly call in here, it's not the other page, but it's on the home page, but simply we are populating the data on in the tab view, so we can directly get in order to not build it every time when we switch between the tabs. So in the init stat, we have to call after this method. So this is my call history qubit, get my call history on my ID. So once I have this, I will hot restart the application for both here and also here. Was generating so much logs, it's the emulator logs anyways, let's keep it like that. So when the application hot restarts and when you go to the call history, you can see we made call on 9:53 AM to the John, and also this time at this time. And for him, when we go to the calls, he received the call from him like that. And now what if the call has been missed? So let's go to the calls chats and navigate in here. Also for him, this time let's say we are again calling to the John. Let's close this, and he received the call, and we navigate to the call. The call will be connected right now. It's connected, and he declined the call from here, and he navigate in here, and let's say he now come back by closing the call. And this time if you go back and come to the call page, you can see he made the call, but it's red because it's missed. And he also go back and go to the calls page, you can see he received the call but is missed. So that's how the history is creating, and that's how we make calls. And yes, for production you have to consider some real service rather than relying on the local node server in order to connect the call for token generation. And that's how everything is happening. And that was the last video of the WhatsApp clone clean architecture. We have built up everything like that, and I uploaded a post in the community, and just to see the votes of the push notifications in the WhatsApp clone clean architecture, and I got so many votes of adding that, and let's see what happens in the future. So that's it for this video. If you found this video helpful, thumbs up a like and subscribe for daily updates. Also, drop down all of your confusions in the comment section or directly DM me on Instagram or LinkedIn. That's it. See you in the next week, or also, if possible, in the push notifications video of the SAM WhatsApp clone clean architecture. Again, see you in the next one.